So the whole field of coordinate geometry, or to give it its correct name, Cartesian geometry, named after someone's thought? René Descartes, a philosopher and mathematician. I guess the first sort of formulas we see in the Cartesian geometry, we're placing points, and basically it's all about how do we describe positions of things and stuff like that. So the distance formula, which essentially is Pythagoras' theorem really, because when you join a line between 2 points, if it's at an angle, you can create a right angle triangle, and the base would be the difference in the x values, and the height of the triangle would be the difference in the y values. And so that's basically where the formula comes from. Some teachers get really paranoid about how you use this formula, by the way. Let's have a look at an example. And they say, no, you must. It's got to be in the same order. You go, what do you mean it's got to be in the same order? Well, you see, if I did the 5 minus the 3 in that one, then I've got to go the 3 minus the 1. And of course that's a pack of garbage, because you're squaring them. So the actual order doesn't matter, because you square it and you'll get the same answer anyway. I think we'd probably say that, so when we get to the slope formula, because that one it does matter that you have them in the same order. So there we go, 2 root 5 units. So as I say, basically it's Pythagoras' theorem. The other big one, I guess, is midpoint. There's a formula for midpoint. Again, the actual order doesn't matter, because adding you can do in any order. Midpoint is exactly what it says, the middle of 2 points, the average. That's all you're basically doing, is averaging the point. So the average of 3 and minus 2 and the average of 4 and 1, and there's our answer. Now, in extension, we also look at division of an interval. See, at the 2 unit level, they pretty much just stick with midpoint. We can find the middle of 2 points, but that's about as far as they go. In extension, we can say, no, why stop with just the ratio 1 to 1? We can chop up a line in any ratio we like, and that's where we get to this idea of division of an interval. It could be, of course, it doesn't have to be an internal division, it could be an external division as well. So what is the difference? And the wording then becomes important as well. So there's an interval, xy, a. Now that would be an internal division because a is on the inside of x and y. And so we could say, if we wanted to describe that point, a divides xy internally in the ratio, and let's put those in, m to n. So the naming of the interval is really important because the ratio matches with the naming of the interval. So m is a to x and n is a to y. So of course I could have said it divides yx internally in the ratio n to m. Okay, so notice the difference. I've changed how I named the interval, but that means I've got to change the ratio around. So the actual naming is important. Now, external is when it's on the outside. So if you, well, what's the word we use when we extend a line? No. What word do we use in geometry? Produce. Produce the line. So if I produce the line out to A, I could say, now if it's A divides xy externally, once again the naming is important. So A to x is m, A to y is n. Alright, let's do some HSC ones, typical sort of questions we could get. So they've given us 2 points, we want to divide it internally. So the way I do it is first step, I'll just write down the points that they've given me. So it was minus 3, 4, 5, 6. Write them in the order of the interval. Then I write down the ratio underneath. Oh, it's 1 to 3. Then I draw a cross. Ah, there's a cross. Then the next thing I do is draw a set of parentheses with 2 vinculums separated by a comma. Ready for my answer. Now, on the bottom of the fraction, I add the 2 numbers together in the ratio. 3 and 1 is 4. So that goes on the bottom of the fraction. And on the top, I just multiply along the crosses. And I use the x values to get the x value and the y values to get the y value. So multiply across. So to get the x value, it would be 3 times minus 3 and 5 times 1. To get the y value, 3 times 4, 1 times 6. And there's my answer, but that simplifies down to be minus 1, 9 on 2. So as I say, I don't use a formula, I just simply draw a picture and draw a cross and bang, there's my answer. Some people like to draw it on an actual number plane and use similar triangles. I mean, you could do it with similar triangles. Let's try this one. This is an external division. So how does that change the situation? So it really doesn't change it that much, other than the ratio is negative. So the external ratio, an external division is a negative ratio. Now, as it's a ratio, ratios are the same as fractions, so it doesn't matter which number you make negative, because minus 1 on 2 is the same as 1 on minus 2, it doesn't change it. I usually make the first number negative just out of neatness, that's all, but no other reason than that. So my ratio is negative 5 to 2 because it's an external ratio. Draw in my cross, but I do everything else exactly the same. Okay, add the two numbers, negative 5 and 2 gives me negative 3. Multiply along, so for the x value, 2 times 3, negative 5 times 9, and the y value, 2 times negative 1, negative 5 times 2, and bingo, we have our answer. 13.4. Okay, so that's how you do internal, that's how you do external. What happens if the question isn't in fact to find the point, but the end point of the interval? So in this case, they've told me the answer, if you like, is 1, 4. Well, again, I'm going to do exactly the same. So it's minus 1, 8 and xy. I don't know what the other one is. The ratio is 2 to 3. Draw my crosses, but this time I actually know the answer. So to get the x value, the bottom of the fraction would be 5, multiply along the crosses, negative 1 times 3 plus 2 times x. And I've just got to solve that equation. And we end up with x equals 4. To get the y value, do the same thing. So I know the answer is 4. So I get 3 times 8 plus 2 times y over 5. Solve that equation, and I get negative 2. So B must have been the point for negative 2. That's one way I could do it. Another way I could do it is I could change the question. Okay, so what they're saying is, we've got this interval AB and I want to find B. They've told me it's an internal division in the ratio 2 to 3. Well, that's the same as saying B divides the interval AP in the ratio 5 to 3. And now it just becomes an external division of an interval. So I can set it up like that. And I go, well, they're the 2 points I know. The ratio is now negative 5 to 3. Draw my crosses. And the bottom's negative 2. Multiply along the crosses like I did before. And sure enough, I end up with the same answer. So that's an alternative. You could rewrite the question to make it something more familiar. Well, what happens if it's the ratio we have to work out? So they've given us all the points. What's the ratio? Okay, again, I'm going to start off exactly the same. Well, the endpoints are 6, negative 4. The ratio, well, it's k to 1. I'll make it negative k to 1 because they told me it was external. I suppose it doesn't really matter in this because I could have left it as k to 1 and then k would turn out to be a negative number. Either way, it doesn't matter. In this case, I'd expect k to be a positive number because I've made it negative k. Draw the crosses. Now we know the answer. Now theoretically, I don't have to do it for both the x and the y, because if the question is correct, then it should give me the same answer for both. So I just use the x's, and I know the answer for x is negative 3. There's my equation to solve. Wasn't that nice? K times 0 on the top. That makes it a little bit easier. So I end up with k is 3. K is 3. So yes, P divides AB externally in the ratio 3 to 1. Now, had they not given me k to 1, then I probably would have just gone, I don't know, m to n, a to b, something like that. I would have created a fraction. But remember, when you do it as a to b, you don't actually need to work out what a and b are. you'll end up with a fraction A over B equals something. But that's all you need to find, because you just want the ratio. You don't actually need to know what A and B are, you just need to know the ratio A to B. So if they didn't give me that K to 1, that's how I would then do it. I'd do it with an A to B. Okay, 5A, a lot of familiar coordinate geometry questions, but also a few of these division of interval ones as well.